Hi everyone, in this video we will be going over graphing systems of equations. Our essential question for today is, how is the solution of two linear equations found? So once again, how is the solution of two linear equations found? Now we're going to go over three different types of solutions today, but the first one we're going to focus on is the one solution. And when you think about solving equations, say you had something like 2x plus 4 equals 8, you would solve that equation to find out what x is. The difference now is that when we're solving systems of equations, we're finding out what is y and what is x. So a system of equation is just two or more equations that are working together. And you'll see this written as a set of equations. So I've got one equation, and I've also got another equation. Now these are two equations, they work together, and our goal is to find out an x value and a y value that cause the equation to be true for both. So for instance, if I have 0 and 2, then that would be a solution for both, and they would check out. And this will make a little bit more sense as we start going through it. Now our steps are very simple. First, graph the linear equation, or graph the first linear equation. Second, graph the second linear equation. And then you're going to find a point of intersection. So where does it cross paths? Where do those two lines intersect? So our first step, and this is all very familiar, and I highly suggest that you have graph paper to add to your notes to go through this with me, is that you first find your y-intercept on your first equation. So I've got 4. And then my slope is going to be a negative 1/2. So I go down 1 and over 2. You plot your points and draw your line. Make sure it stays a negative slope. On the second one, my y-intercept is negative 2, so I go down 2, and I go up 1 over 1, all the way until those two lines cross paths. So it's very important that you draw those lines long enough. Now, you can see that there is a perfect point at which these two lines intersect, and that is our solution of our equation. And so our point right there is 4, 2, and that means that if I was to plug in 4 into the x and 2 into the y, it would be a solution to both of these equations. Now the best way to check this, and I'm not going to spend too much time on this part, is to just plug it in and check your answer. So it should look something like this. You can see that we have our two original equations, and what you're going to do is plug in 2 for the y and 4 for the x. And then you simplify all the way down, and if both sides are equal to each other, then you know that that is a solution. Same thing over here. I plug in 2 to the y, 4 to the x, and when it gets all the way to the bottom of the equation, when you've simplified it as far as you can, if the two numbers are equal to each other, then you know that that is a solution to the equation. So in this case, you can see on both sides, they all simplify down to being 2 equals 2, and 2 does equal 2, so we know that 4, 2 as our point of intersection does check out, and that is a solution to both of these equations, not just one. Now, another way to think about this is, what if I said, what about the point 2, 0 that you see right here, where there's where this line goes through it, but this one does not? So if I were to plug in this point to our second line, yes, it would check out. But if I was to plug that point into our first equation, it would not, and that's because that point does not lie on that line. So let's look at another example. This one's just a little bit different. So again, you're going to graph both equations and try to find the point of intersection. So first thing I do is I go up 3 on the y-intercept, or on the y-axis, and then we will go down 7 and over 4, or up 7 and over 4, either direction. In this case, we're going to have to go down 7 because I can't go up 7 because there's no room. So I draw my line, and it's a very steep line, and make sure that it is a positive. Now, if you remember, y equals negative 4, there is no slope to this. Basically, we look at the negative 4 on the y line down here, and we know that it's going to have a straight line going through it. Because think about that, there's no slope, it would be a 0x. So we know we've got to have a 0 slope, and it's going to go straight through that negative 4 point. Now again, we have a point where it does intersect, and that point is negative 4 and negative 4. But we do want to check our solutions to make sure that that is true. And if we were to plug those in, see how nicely this works out. You can see that as you go through simplifying, and like I said, I'm not going to spend too much time on this because you guys are really comfortable with simplifying and checking your answers. But as you go through and you check your answer by plugging in the point of intersection, you can see that it equals -4 does equal -4. And over here, that's very simple because you don't even have to simplify. And again, -4 does equal -4. So that checks out, and that means our equation is correct. And that -4 and -4 are solutions to both of those equations, not just one. Now let's look at one where there's no solution. Now if you remember back to solving equations, we talked about times where there was no solution. And usually that was where you would simplify the expression and you get all the way down to the end of simplifying and solving your equation, and you would have something like 0 equals 2. And that's not true, so we would know that it's no solution. But let's see what that looks like when we graph linear equations. Now, when we look at this, one thing to note, first of all, is look at the slopes. They are both the same, and that's going to be very important in a second. Now, in our first line, we've got -3, so I've got my y-intercept is down here. And then I go up 6 and over 1. And it's a very, very steep line. Okay, and I've got to make sure it stays negative. Now, our next line starts at the 1, but again, it goes up 6 and over 1, or in this case, you might have to go down 6 and over 1. Now, look at those two lines. Because they share the same slope, they're never going to cross paths. They're never going to intersect. They're never going to have a point of intersection that solves each. So what this tells us is that there is no solution because there is never going to be a point where both of them cross paths. So the big thing to see here is the minute you see something with the same slope, that's going to be kind of your indicator that it's going to be no solution because they're never going to cross paths. But you do have to be careful because there might be times where it's not no solution and it might become many solutions. Now you cannot check this answer, okay? The only thing that you want to do to check is that they are parallel and that they will never cross. Now let's look at one more. In this case, you are going to have to do what we did in our last lesson and turn this into the slope-intercept form. Or into the, y-intercept, slope-intercept form. Right now it isn't. So make sure that the first thing you do is you convert those into the slope-intercept form. And I'm not going to spend a ton of time on that right now because we have been doing that for the last couple weeks. So if this part still confuses you and you're not sure how to get from there to the next to slope-intercept form, make sure you see me and we can sit down and go through this. But again, we just convert those into slope-intercept form by making sure the y is on the left side by itself and that we've got our slope and then our y-intercept on the right side. Now, immediately you can see that the slopes are the same, but they have different y-intercepts. So when we graph these, it does end up creating two parallel lines. And because those are two parallel lines, they will never cross. So our answer then is no solution. Make sure you are writing these down on your graphs and taking the moment to make sure that you have written them out correctly. All right, now let's do one on many solutions. Now, you have to be careful and not just think that if it has the same slope that it is no solution, because sometimes it could be many solution. And the big hint on many solutions is, if it is many solutions, is that it has the same slope, but it also has the same y-intercept, okay? So what I've got here is a line, and when I draw that line, it looks like this. But if I was to draw that line again, I would have the exact same line right on top of it. And what that means is that there are many solutions, that there are an infinite number of solutions that will cause this equation to be true. For instance, at 0 and -2, if I plugged that in, it would be a solution to both equations. But also at 0 and, that before was -2 and 0, but the same thing for 0 and 4, if I plugged that in, that would also be a solution for both of these numbers. So that means there's infinite number of solutions. There are many points in which you could get points of intersection because every point that they share is on the same line. Now again, to check the solution, you just need to see that the two graphs are the exact same and that they lie right on top of each other. Now one more example to go through. Again, you're going to have to convert this into slope-intercept form. So if this concept is still kind of new or confusing to you that we've gone over the last couple weeks, let me know and we'll go over that part. But once you convert it into slope-intercept form, you graph your lines. And again, these are the exact same two lines, so they're going to end up on the exact same line on the graph, which means that it's going to be many solutions. All right, you have a couple practice problems to try that are on your Foldable. Give it a shot, and then we will review them in class.